Hello. I think it's time to make a small coding session. Maybe a bit of a short one, hopefully, and a freestyle one. Cause I was just gonna talk about some things I'm looking right now, and that's not just in. I'm using my engine for an example. I was looking this on OptiDoom mostly, but I ran into some problem. I learned some things and I ran into some problems. And the thing is about the VDL. The thing is about this. First of all, this part of code. I can try to do it here. I'm gonna run this for convenience. It's going to be a bit higher so that it loads a bit faster. So when I did that, this happened. And you see that all the color palette become a bit too purple, and maybe the letters are not white, they are some bright blue cyan. I also have removed the collision detection because I was testing something. So what I have done there, it's a part of 3DO I'm looking right now, and it's fascinating, but I still need to read more about it. And it's about the VDL. Now I'm gonna see. I have loaded a lot of stuff here because this information is lost around, and I need to see. There is a lot of things happening till you see graphics of the 3DO. And previously for the majority of the time you would think you have the cell engine, of course, and you have a 16-bit or 15-bit color video RAM. Now those pictures are a bit horrible in the original documents. So that was the resolution, 320 by 240, 15-bit color values. That was the video RAM that the user programmer would usually have in mind. Like, okay, this is where I write. I don't think much about it, especially if you are a new programmer. Just prepare your cells and render stuff, or you could also do software render in the video RAM. You can access that too. But there is more to it. There are a lot more paths. And one interesting and very useful path, and very easy to use most of the time, is especially if you set up your screen in a regular way with some high level API functions that gives you this 320 by 240 NTSC resolution, or it can give you a palette NTSC. Although you can set up some other ones. You might do that and forget all about it, and then you can use certain functions to map. Let's see here. The RGB 5-bit channels, which have values 0 to 31 for each channel. So it's 96 values. You can map them to 24-bit. What is displayed is really a 24-bit color value. But this is not in the video RAM. That's the important thing. In the video RAM, if you read a pixel, it's going to be 16 bits per pixel, where the 15 bits per pixel are used normally for a 555 RGB, and the other bit can be used in various ways. And then that also passes from the interpolator. I haven't figured that thing yet. That is doing a pseudo 640 by 480 resolution by interpolating. I don't know if this is here. Some low and high bits in various ways, either coming from the cell texture or the pixel or other places. It's so complicated. I haven't even managed to figure this out yet. It goes further. It will, depending on 4 combinations, it will know what kind of averaging to do for this 640 by 480 resolution. But the important thing is that initially this 640 480 24-bit color, it doesn't exist for the user programmer. When I say the user programmer, is you only see the 320 by 240 and you work there. You kind of forget about that. And I don't know how easy it is to do something useful with the pixel averaging weights, especially in real time. But there is one thing that you can control, and this is the mapping from the 15-bit to the 24-bit color palette. Now I'm making everything big, but I need to find what I mean. There's so many information. So much information. I know I should have made some modern pictures for these things. But now I'm relying, because this video is a bit free-flowing, I'm relying on what is here. So when you set up a regular video mode, the translation between the 15 bits per pixel, 5 bits red, 5 bit green and 5 bit blue, to the 8 bit red, 8 bit green, 8 bit blue for the 24-bit output display. They are initially set up with a default fixed linear palette. So there is not much different. You could work on the 15-bit color palette and never know that there is a 24-bit output, because they are gonna map linearly in the 24-bit. It will read the 5-bit and will shift left by 3 bits. But the good news is that there are some high-level functions that makes it very easy to change that mapping. Assuming you set up your video display, your screen correctly, either by creating a, let's see how I do it, because here it gets a bit complicated. You have various objects, screen groups and screen items and so on. But I think here on the init, there are various ways to set up your screen. I might just call some other high-level function, create basic display. And you have some enum that gives the, NTSC 320 by 240. You can make some PAL resolution. You can make a PAL 320 240. But we are gonna come to this later. The reality is that in a more detailed way, there are special functions, set VDL, submit VDL, modify VDL, that they will set up these screens. And I'm going to show you something more. Oh my god, there are even kind of different modes where the low and the high bits. It's the 555 RG bit, and the 1 bit is define something with the corner pixels. Now the blue bit from the low is used for the second corner white bit for the high res. And then I need to see, maybe the Doom is on these modes. I will tell you later why. Because the high bit will select between those color mapping from 16-bit to 24-bit. Will be able to switch it at different pixels. But initially, now I'm sorry about that, but let me find it. I had it here. The more interesting thing, which I really need to read about it, here is the thing. When I call these functions for 320 by 240, when I call this one, I assume, I haven't seen the code, but I assume it would create a default screen. That is a full screen 320 by 240. But with this VDL, the video display list processor, it's bypassing the process, and you can define, that's the interesting thing I need to say. You can define different screens. If this is a 320 by 240, you can define this screen and that screen and that screen to be three different. You can do actually some kind of line splitting like the old like Amiga or CPC in a way, but easily defined by the hardware, so it doesn't need some crazy timing like the CPC. It could be similar to, or maybe not. I have no idea. The concept in high level could be like the copper list in Amiga or something else, where you can say, you know, here is the first screen. It could be 50 pixels, and then this could be 100 pixels, and this could be 80 pixels vertically. And that means that you can have a different palette here, different palette here, a different palette here, and possibly different video RAM start address and a lot of other stuff. You can define a lot of stuff for those VDLs. And here, for example, it has this example, and it says, if you have a flight simulator, and this screen and this, those are two frame, different frame buffers. It's for double buffering. But those upper and lower parts are the cockpits, and it's stable graphics that don't change. Maybe you don't need to define the dual buffer for those, but only this middle buffer where the graphics are changing. You can define a bitmap 3 and bitmap 4 to do double buffering so that you save memory when you use double buffer. There are things like that. I could even think about doing that on Doom 3DO, on OptiDoom. For the lower bar, that is the player bar, you know, with the face and the remaining ammo and health and armor. Yeah, I could, yeah, because I don't think it's done right now. I could save a bit of memory. So you have more control over portions of screen, where they look in what's memory address in the video RAM they look, what kind of characteristics they have. And you can definitely change the core. You can have one portion using different color mapping from 16-bit per pixel to 24-bit per pixel, from 15-bit per pixel. And ideally, you could split the total screen in several scan lines. You could do some raster effect if you wanted. But you know, most of my examples, possibly many games, it's very possible that they only use the one total screen. It's very possible that a lot of projects never bother with splitting screen, and some of them might call this function or maybe some other function to set up directly a 320 by 240 and never bother with that stuff. And I will show you later why this matters in OptiDoom, because there is something that the original commercial Doom, which is also maintained on OptiDoom, does that I need to figure out. But here is the thing. So in my example, I could very easily use the command set screen color to create those lookup tables from 5 bits for red, green, and blue to the 8-bit red, green, and blue. This is great because you can you could fade out the whole screen. You could colorize the screen. You can make things more blue or more red or more green or more. You could possibly invert the color. So here I have this test VDL that I call at the end. And you have to refer to the screen. You have to get the screen item, that object. And I do it for every buffer. And these are the 32 colors. And that's a high level function that works very well. You don't need to do anything low level. Now make color lookup, and let's keep that. Are these 3 numbers? So this need a number from 0 to 255. So this will map the 32 colors to that. For example, and J is from 0 to 31. If you do shift by 3, I think, yeah, for red, for green, and for blue, this is going to give you the default fixed color palette, which is what we had in the beginning. Oh, wait. Did I compile that? Ah, okay. Yeah, is it? Yeah, okay, I forgot the parenthesis, sorry. Man, what's going on with you? Why even the most basic? What have I done? What an idiot I am. Sorry, I'm an idiot, and it's harder when I present this video. Yeah, this make CLUT color entry, obviously. The first color is the color index. But it's the color index for all channels, but you can set it channel separately. No, the color index for... So if this goes 31, you would affect the brightest red, brightest green, and brightest blue at the same time. But you could give different values. You could say, okay, the brightest red would be 0, the brightest blue would be... Now if you do this, you go through all of it. Now this one will remove, there will be no red. Everything will be green and blue. Let's try this one. The previous one would give the default colors, but we don't need to do it. Yeah, so you have only green and blue. And it shows there is no red. And if you put it 255, this means is that the darkest red will be the brightest red. The darkest red on the 5 bits red channel will map to the brightest 8-bit red channel. The rest will remain the same. No, the darkest one will... The 5-bit will map linearly to the 8-bit green and blue. Now everything is red, no matter. Except the black, of course. A quite red display. See, you can do something like that. Or you can give a boost to the color. You can say I'm going to the darkest blue would be 64 plus or 120 plus J 2. So J is from 0 to 31 for the blue. Shifted left by 2, it's multiplied by 4. It's 0 to 127. So this color will be 128 to 255. But what is it gonna map? It's going to map the red from 0 to 31. The red from 0 to 31 is going to map to 128 to 255. So the bright red will be bright red normally, but the darker values will start much higher than the rest. So the 0 is not mapped anyways. The 0 remains black as far as I can see alone. It's an exception. Is the red one will be 128 very fast. Instead of it should have been 4, for example. So you can give a boost up to. Did I build it? Okay, that also builds it. So now we're making things bluer, but not extremely blue. Oh, and why? Okay, why is it yellow? Ah, because see, there are things now. This is the blue, is it, or is this the green? Is it the green? Ah, hold on, yeah. I think that's it. Be careful of parentheses. Just saying. See, if I am to present something in free flow, I'm making many mistakes. Yes, that's it. Now I gave a bluish. Maybe still too blue. See, that's what I mean. So finally, I'm going to try something. I'm going to do two things. One thing is, how about setting some random colors? This is my function. Gets a random number from 0 to 255. But I think it uses randomcy. Just I can give any range I want. How about that? How about giving random color, totally random mappings? Oh, actually I haven't tried the other one, which oh, it does it continually. Huh. Hold on a minute. Ah, I know why. I thought it would do them once. You all know why it's doing it continuously. Because I have several frame buffers. Funny, isn't it though? Because I'm getting random numbers for 0 to 31 colors, channels. And then I repeat this for the next buffer, for double buffers. So every buffer has its own palette. You know. Yeah. The good way to do that would be to calculate this once outside and set the same on the same frame buffer. But anyway, I want to try some other stuff later. I wanted to try. I'm calling this on init. I wanted to show you that you can do it even in real time later. Also, that seems like real time, but it's just different pre-calc mappings of the palette. So I didn't try the little one I wanted to try, just to see how it looks. Hold on. Oh god, I wanted this one. So all I wanted to do is reverse. So do a 255. I wanted to invert the color. You can invert only the red channel, only the green channel. And I find this very useful because you can have a regular game that you know, this is the palette of the final screen in a way. It's not the palette of the individual. You know that the cell textures also have palettes. Some texture might have a raw format, no palette, just 16 bits, which really is 15 bits for the colors. And there are other format 8 bits or 4 bits per pixel and so on. Oh, inverted. Oh, that's actually what you need for, but I don't get the black color. The background, because the black color is the background color here. It's the transparent color at this point. So this is how you do the invulnerability in Doom, in a way. This would be good, but I would have to swap the background too. And the reason the background is not swapped is because it's the transparent color in this one. And again, remove some of this, make the green normal. Well, just showing stuff because it's fun. Hopefully it didn't. I haven't seen what it did. And you keep getting some other kind. Regular blue and inverted everything else. Ah, that doesn't look good. Anyway, you get it. So for the final test, I want to see if I can affect... Let's take this one that affects the blue. I want to see if I can affect in real time. And instead of 128, we will put a T. But it's going to modulo or end by 127. And I want to see if I can do this here, for example, while getting a DT. We'll see. We'll see. Maybe put some starting in. Maybe put something that we will increase. So all I want to see is oh, come on. Okay, hold on. Yeah, okay. Sorry about that. Yeah, I just changed that. How much harder it is to present things than the way I have them in my mind. I guess when you're trying to present and so at the same time you do all sorts of mistakes. You don't have the full focus. But anyway. Ah! It goes much slower, of course, because the way we do it. So do you see that it slowly gets more blue? Repeats back to, it becomes a bit yellow when it's low, because when it's low the blue is from 128 start it's 0 and the rest goes from 0 to 127. Might be hard to see. Ah, you have seen it. Let's make it faster. Of course, now I'm calling all the get rand functions. I'm calling them on the several frame buffers I have. So it's not fast. There is a drop in the frame rate. You see the color changing. And I don't need to do that. The color palette of the whole screen. And you know, this is great because you can have a regular. If you wanted to fade, and you would have to go through every cell, read the palette of the cell, and some cells don't have palette, and fade each palette individually if you want to do some kind of fade of everything in the screen. Or you would have to do software rendering on the final video RAM, but you don't need to because you can change the final palette of the screen to do fades. I'm thinking to use it for gamma correction in OptiDoom. That would be very, very useful. So it's like you have an extra layer of colorization. So you can make a game and maybe you want the game to have a slight green or slight orange. You can use it for effects. I'm thinking to see if I can use it in Doom to replace the way now it's done. When you get hit and the screen turns red, it's not done using this one, but just with a additional cell rendering of a quad with blending. So you can do also now. Here we go through all the total buffers now. It might be that they are 6 now, the way I set up it. So why not just go for the current buffer? Do I have a current buffer? It has to be the buffer index. Okay, screen page. So I have a screen page and that's the current page, I think. Draw cell to the screen page. Now I don't know if this is synchronized. Just to make it a bit. So don't change the palette of every buffer all the time if you are going to display. No. Screen page. See. And of course the call to... I'm not calling the random. Get random. It would be even worse. But anyway, you can do it effectively. I'm calling set active color many times. That's the other thing. Yeah, it's much better now. So this is how you can affect the global palette and colorize your scene. It's good if you wanted to make some cinematic. I see that certain movies have a very tiny, very slight colorization at the end. Like the Matrix has a green feeling because it's the Matrix, you know. And other movies have a bit. And artistically, it's interesting that you can do it you don't have to do it individually on your cell textures or other bitmap graphics in the background. You can do it one for all. Pretty cool. And finally, I want to say, I mean, it's not just 32 entries, but still, we call, to change the palette, we would call set screen color. We do a function call many times. I don't know if this function call is an SWI or a regular. I think it's a regular function. So I want to say that you have set screen colors where you can pass a table with all your entries. So you don't have to call 32 times set screen color. You have I call that too. Make CLUT color entry. Yeah, so this one takes a value 0 to 255, 0 to 255 for RGB and the index color, and it returns you a value to pass to the set screen color. And the reality is do you also pass? Yeah, you pass that. The reality is, I think I have seen that in the Opera source code, and it's just bit shifting or something like that. I think it's bit shifting to the 24-bit value. So, some of these functions, they are not very low level, I think. So you could have write them yourself, but I guess when you affect the VDL, it might be more where they end up. You can do it for only the blue entry, only the green entry. You can do it separately for a channel if you don't want to set everything. So there are various functions here. And one final fun thing before we proceed is I tried to make the RGB wavelet with a sine with different frequencies. Let's see how this looks. Yes, fun stuff. And that's it. Those are the regular stuff you can do with the VDL palette mapping. But there is more. I need to see how to create my own screen groups, how to split multiple of them. These are high level functions. If the screen is already set up by other functions, this will just work. But here is the problem I got into with OptiDoom. So here is what happens with OptiDoom, and that's also from the original commercial Doom, 3DO Doom, that I never touched this code. It's not calling a high level function to set up a default video mode. What it's doing is something else. It is defining a static array with a lot of VDL arguments in series that will set up something a bit different. And generally speaking, the 3DO Doom, the rendering screen is 200 pixels on height and not 240. Because, as I understand, I need to read more about most of these flags, but here there are 20 scan lines. Up in the upper part of the screen that are blank in a way. They are not for rendering. There are 20 scan lines. I need to understand some of that stuff. And set the screen to black. Now there are some knobs because this has to be aligned to 16 bytes. And we see this repeats here. So this is the second, this is the main screen. You know, in the same way, if I can find it. That instead of this screen, that was split into a central screen, an upper and a lower. I think it sets something like an upper part of the screen, just 20 lines. And with certain values it sets it's not going to render anything, just black screen. And then here starts the central screen with 200 lines, although it says 198. So I'm not sure about that. And then it will set up some extra flags which are different than the upper. Then here, this is the color lookup table. This is the default color lookup table. And you see the first byte is the color 0, 1, 2, 3 and so on. And the next 3 bytes are the mapping, the 0, 0, 0 RGB to 0. This is 888 because it's 1, it's 0 to 32, it's 5 bits mapped to 8 bits. So everything is multiplied by 8, hexadecimal 10, so 16, 24 and so on. So these are the default linear mapping of the pellet 1F, and then it has the E0. This might be about the border color, I think. Set the screen to black. And then you need some knobs to align to 16 bytes. And then you have another one. And you put a 0 for some reason. I think this is to terminate. This is to say, I need to see it, of course. We don't have a third screen. We only have here like bitmap 1 and bitmap 2. Not even bitmap 1, even bitmap 1 is black. So after 200 lines and the 20 above, it stops. It doesn't do anything with the 20 below. So this is set up to terminate. We have the central screen. The one above is for centering. The 20 lines above is for centering the screen. And then we have the one below. And you will... That's a way. I haven't seen it in the docs. I will show you. This one that is manually created. This is passed at various places, but there is this submit VDL. This is another API function. I need to see an example for this. Because here there is a set VDL, of course. That's a modify VDL. I think there was a create VDL, but maybe I'm wrong. I will see about it. Because there were some examples, but I don't remember if they did what the original Doom did, but maybe they did. So, and here is my problem. let's be brief. Here I was calling this function. Maybe I'm doing something wrong, but if I call this in OptiDoom, nothing happens. It doesn't work, because I don't know what the hell, if it should work with a custom VDL and a custom VDL of that type. So the best thing I could do was to, I count here, okay, this is 0, 1, 2, 3, 4, 5, 6, 7, these are ORs, 8, 9, 10, 11, 12, here is 13. So what I did, in each screen VDL, I made the pointer to look at that place where the palette starts, and I set my own palette. Okay. I played with the colors, but before I submit this VDL and set this VDL, you have to set in all the screen items, and the I is the number of screens. If you have double buffering or more, for example, number of screens, you have to set it separately to all of the screens. So I'm doing this. Very early before the screen init. And you see, even the colors here have changed because I use the same screen. You see that above and below it's letterboxed because it's 200 lines and not 240. Forget about this counter, I was testing something. And you see now, I managed to change the palette. And that's the purple Doom. Nice. So much later, let me see. I tried with various examples. I have this update screen VDL, and in order to make it work, because if you change the colors, it's not reading that array. You have to call again, submit VDL and set VDL, and I don't even know, and that's what I'm doing here. I even have to do that, change those values to the screen maps for some reason, but why? They are already changed. For some reason something went wrong if you didn't do that. Or maybe not. Maybe I'm doing something bad because it's very hacky. But right now, see, I have it commented down. This is on the main frame loop. If I want to use it for something more real time, and I really didn't like that I have to call all this submit VDL, set VDL per frame, because I don't think that's a good idea. Performance wise or system wise. Depends on what they do. Because I couldn't affect the colors normally with the high level functions, and I need that. You don't even get the right colors. Something went wrong, man. I don't get it. So I'm in trouble now, and I have to understand this. I have to even make an example where I create my own VDL. I could create multiple screens, I could make raster effects, split maybe the screen in many scan lines. I could do some other, outside of OptiDoom, in some other independent experiment I could I could waste some time to understand how to do this properly. You know, because I need this, I need to, after the game has started, I need to have a menu to set up a gamma correction and change the total luminosity. It's not going to be some absurd color stuff. It's going to be everything goes brighter or darker through a gamma correction bar. And maybe I could use that if it doesn't waste performance to change the color on the fly when you get hit by something, when you get the radiation to it, instead of the way it's happening right now. But I need to see how to do this properly. Even in an empty project where I try to create my own custom VDL and see if I can get it right. And there are examples. And now I'm going to show you something different. I'm going to run the same thing on Phoenix because I think I've done something extra. This one is a bit funny right now because I was testing something purposefully. It's not going to be total black, it's going to be more interesting. I think, let's see. It is almost total black now. Welcome to Bizarro Doom. Oh, what's going on here? It's almost black, but I see some overlays, some stripes. Whoa. Now if it goes fast, it might be because I overclocked. So let's be in normal speed. I don't want to surprise you and say, hey, it's going fast, what the heck have you done? Maybe it's the stripes. Look, Bizarro, these are like ghosts. Look at them. Bizarro Doom. That's a different kind of Bizarro. Good shot there. Welcome to Bizarro Doom. Enjoy your stay. I will tell you what that is. And I have another video because I don't want to hack it now. Or I could hack it. I could hack it right now. I think I could hack it. And I will disable this. I will keep the default colors. Put something nicer maybe. Yeah. And I'm going, I hope that's fine. I do that. Yeah. I'm going to do one thing which might be here. And I'm doing already, I think. Let me see it. Phase 6.2. Oh, I do it like that now. I have it left. Oh god. Yes. Every few stripes in the CCB area of these whole columns, I would do something with the flags here, and there was something that was a reminiscence of the old original commercial Doom code, something I never tested back in time. And it was this. Let's see that if I did things right. And this only works on Phoenix, and it also works in the real 3DO. So the 4DO is not doing it precisely. In the 4DO, if you change the VDL color LUT, if you change it, it changes for everything, which is what I would expect. Okay, because you change it for the screen. I thought you did. I thought you didn't. Ah, those are better color. You didn't change it for individual cell textures or something, or pixels. But here is something I learned. Yes and yes. So the color have changed, but the whole columns are still displayed with the original, the default fixed palette. How about the enemies? No, the enemies are... So the floor and ceiling is with the altered palette, and the walls are normal. I also noticed then that if I change the screen size, no, sorry, if I use the scalars, suddenly it changes. There is another reason for that. It has to be with the individual cell elements. Because I render in a back buffer and I use another cell that doesn't have this issue, it's fixed. Also the polygons. Now when I go far away, when there are columns, whole segments far away, that might not be very optimized with individual. Because they might be very thin, like 2-3 columns. It switches to those instead of the polygons. When I go close, I use the polygons. Far away, I might use, or even when you go very thin, that goal here on the column, that there, it might be 2-3 individual columns. So I found that that was the part of the ordinance. So I switched to the original column rendering instead of the polygons. But when you go close, like when you go to this door is one big quad. And also it warps, if you see. But that's not the point. That's why you have the change. Because the only cell elements that are not altered by the palette are these columns. And it took me a long time to see why. What the hell? First of all, again, what I have understood initially about... let's see that picture again. Where is it? Ah, I'm missing it. Yeah, what made an impression to me about this VDL and the color look up table and also the whole VDL is that you could. I had the impression that it happens after all the rendering, so it's the final frame buffer rendered to the screen, and then you could change palette, and also you could set up this to be split in individual different screens, micro screens making the big screen. But I thought these were, you would only be able to affect different colors here in a split screen manner. But as you have seen there that I closed, we have different cell elements, different columns. We have different parts. It doesn't have to be horizontal scanlines. I was like, what the hell? When you read a little bit about this, it gives you the impression that's the only thing you can. I mean, no, wait. The screen is still defined like this. But there is a catch. And the catch is. And I might have to find it again. There is a custom color lookup table. Those are the new colors we made. The mapping from the 15-bit to 24-bit. From default values to different non-linear values. The fixed and the fixed one, this is still kept intact. That maps to the original values. And somewhere here it says maybe it's not here. There are certain display modes W corner value. I'm not sure if it's this, and I have to see that. So there is a way to switch between the original. I closed that. The original color mapping and your custom color mapping, the fix and the color. There is a way to do it per pixel. It doesn't have to be per split screens, which is amazing. You could have a big boss. The big boss could be made like a big spaceship. Could be made by several different cell textures, with some cell texture having their own unique palettes. Some cell texture have a raw 16-bit. You know, you can make a monstrosity that has different formats in the cell texture. It changes the cell palettes individually, and then when you shoot that enemy, it also flashes to white, like the old shoot 'em ups, for example. You can do such things. Or if you also split the frame buffer, not in 3 parts, if you split it per scan line, you could do some raster effects thing inside that boss, but not affecting the outside, the background pixels. So you could do some pretty interesting tricks if I manage to understand what's going on. But that's what surprised me. And let's see it here. Here I was kinda talking get out about this. I was playing with that, you know, I was trying to. Because I'm like, how the hell those individual parts use the default palette and the other? How is it not affected? That surprised me. I thought I could have only horizontal screen areas that are not affected by the palette or have different palettes. But as you can see, you can have individual cells that you can switch that on and off. But it's going to switch between the default fixed palette and the custom palette you made for that screen region. If it's not the full screen, if you split it into more, it will change for that screen region. So you have one fixed palette for all, and the custom color lookup palette for the screen region this cell is sitting on. It's interesting. Also, I read, again, it's good to see that if you split your total screen in several screens, you could render, if you call draw cells, you have to specify which bitmap within a screen. This bitmap items you set up. So you might draw some sprite or polygon. If it's bigger than the screen, it's going to be clipped. But if you call draw screen cells, it's going to be drawn all over the place. So you could have clipping areas between all the screen. You can draw something in the central. If this and that upper and lower are some cockpit, it's gonna be inside the cockpit. You can do such tricks. And I know there are some functions that set clip origin, set clip width and height. That will affect the bitmap item of the screen group. And I know Doom is using that. And I think it's using to clip against even in one screen. Even if Doom defines a central screen, it's using the clip origin, clip width and height and origin to clip the cell in a smaller area in that screen. And this is because there is the bar here. You have the outside border, so Doom is using the original commercial Doom. I haven't changed that code to also clip there. So finally, I was looking, I just changed the palette and I see that thing and I'm like, that's only on the real hardware or the Phoenix emulator, the good emulator, the more accurate. I was like, how the hell can I select which cells to be affected by the palette and none? How is this even possible? I was looking, I couldn't find it. It's obscure. And what was it? It was that. This is obscure, by the way. This is the vertical position of the in the cell code, the corner, the upper left corner, for example. I call it upper left, but it can be the starting corner. Can be depending on how you rendering the direction of the other vector can be anywhere. So the starting corner, one vertex of your quad, it's a 16-bit fixed point. But here is the subpixel part, and this is not mine. This is what Becky had done at the past. For some reason, Becky would or with the 0x000F, and it was done here. It was done on some other part. It's not done everywhere. And if and that's the subpixel. That's not even. I initially thought this is some kind of centering on the subpixel of the column. If you change it, it's almost the same positioning. And look, if you change it now, it took me some time to figure that out because I was suspecting a lot of other places in the cell. Now everything is fine. Everything is affected by the palette. So, and that's the weird thing. This is the position, the geometric position, of the cell. the starting corner, the vertical position, the starting corner. This top is the integer part, is the pixel coordinate, because it's shifted by 16, and this one is a sub-pixel offset. And generally speaking, I realized by trying other things, I realized that this one, if you do that, it's the same. Because it's the last bit, the 15-bit of the low 16-bit part of that fixed point. So from the fractional part of the fixed point is the highest bit, the 15-bit, that will enable or disable. So you didn't even need the FF00. I don't know if there is another. Maybe there are more bits that are affected. But look now, this is going to block it from, this is going to make it use the default pixel palette, unless, now I didn't forget about this, and unless on the flags I also use the CCB CLUT pos, which CCB CLUT pos, See how it's so complicated, man. Which is amazing, because using I'm still lost in this CLUT pos. And look now, it doesn't say that it affects the selection between the fixed color palette and the custom color palette. If this is on, get the VH value from CLUT. This is, now wait, this is not the CLUT. Okay. You have the SLUT and the CLUT. Let's separate. This is screen bitmap from 15 BBP 5552 mapping. This is individual cell texture palette if it's palletized. Okay. So this was absent though. And it says that this VH value, if this goes on, it will take it from the parallel lookup table. And maybe this is the, again, the 15-bit, the last bit on a 16-bit palette, because the palette is 15-bit, it's 555 RGB, and there is one bit that is left to use for whatever else you want. So you could create individual color values in the palette and then paint your texture in a way that certain pixels, certain texels will switch to the fixed palette and not. But we don't use that. We didn't use that when we had the problem. Then it was this one. This is how it was set. Get VH value from subposition specified by origin location. And as I said, this is the subposition. Here, it doesn't say if it's a vertical subposition or horizontal subposition. So it's not... I try to also alter this. I try to do something like that. But this one didn't have any effect. It's only this one that has effect. So if you affect the subposition, and I'm telling you, if you do that, which affects the high bit, if these are the 16 bits, this value will affect that, and that will disable that extra palette change. If you do that, it's going to do, and that I've tested, it will not affect, so it's definitely the last bit. So if you do that to the position, that's a subpixel, it's not going to move dramatically the vertical offset. It's going to be, if it moves at all, I don't know. If that bit is used there, and so it's not affecting the movement at all. If you do that, and if you comment out that, you will disable the palette for those cell elements. If you keep that down and you enable that, it will not, this will not be taken into account, and it will set that on the palette. And I haven't tried that. I haven't tried to set up the palette in the way that the 15-bit is on. It's set on. And now it says the VH palette. What is it? Where is the VH value? It's not, as far as I know. It is not initially the selector. Now here is where I don't know. It's those corner weight locations. This, I'm searching those. And that's 1 bit for the corner. There are 2 bits here. I don't know if it's the high bit or the low bit. This has to do with the mapping from 320, 240 to 640, 480. I have to say something. This is affected by 1000 things, by flags here and there, whether you get it from the screen buffer, from the palette lookup, from the cell pixel, and I haven't gone deeply, but I tried. There are some functions to enable horizontal average and vertical average and disable. I have done this. I have tried some other flags. I had tried to set them on the beginning of the screen set. In fact, here the original VDL will, if one, so that happens, if true. You can set up even in the my custom VDL instead of calling this function. Maybe this function wouldn't work if it's a custom VDL. I haven't investigated this deeply, but there were a few times I tried to do some experiment on the real 3D. I tried to affect various. My goal, let's see it again. My goal is to stick my face in the screen, use the joypad button, have something drawn, either cell polygons in some various diagonals or pixels or other stuff. You know, I tried various things. I wanted to affect something. I wanted to see the sharpness change. Do you understand? I wanted to, so that I have a start point, so that I say, oh, now something happens. Maybe if I can research it more, I can. I couldn't move any of it, and there are various things. You will see these VH everywhere. The VH value, depending. You have 4 display modes, really. You don't have one, the 16-bit per pixel, you know. One of them must be the default. It doesn't say anywhere that the VH value can be used to swap palette, but somewhere, and that's how I'll finish. If you disable this, somewhere, where the hell is it? Not this one. The 15-bit of this one, in my estimation, why can I not? Will pass, since we have disabled now. the VH will be affected by the subposition on the pos Y pos, CCB Y pos, from that subpixel 15-bit. And somewhere, this VH, instead, it should be affecting the high-res 640-480 interpolator, the averaging. And I read how it affects it. It makes sense graphically, but somehow it doesn't affect, and somewhere, you know, they have all that stuff and more. There's a lot of that, and you will find a lot of here the VH goes there and goes there. Let me find that one. I need to find that one. I've seen a nice maybe it's in the beginning, damn it. Sorry about that. And now it's not here. Oh. Maybe I won't be able to find it anymore. Somewhere this is ending through a big pipeline of things. CLUT DMA control. Oh my god. Those one might be affecting. Do you understand how... this is about the VDL. How complicated the 3DO is. I need to find this, maybe. Sorry about that, but I'm going to finish. Somewhere there was a description of understanding 3D graphics. I'm just doing cycles. Anyway, I can't find it. There. So again, there is a kind of, you know, some pipeline things go there, you get the pixel, they decode the 5 bits to the 16 bits somewhere, and there are a lot of things affecting the VH value here again. The VH value can do things here, or it can be taken from the frame buffer. Usually it's the 15-bit color value, the one that is not used by the 555 color, but somewhere it's going to be affected. And see, if you have, this is on the cell textures, this is not on the scale. These are the different modes, 16-bit or 8-bit. Uncoded means no palette, raw. Coded is with palette, and I see there is a 16-bit coded. Huh. With 32, possible core 32, 32, 768. You have these AMV bits. I know, these are for the blending. You know, the background multiplied by a fraction plus the foreground to do the alpha blending and other stuff, the shading. That's another thing. Somehow there was a better here. If you have these are the cells, these are the cell textures, this is not the frame buffer. If you have a 16-bit, which is 15 bits, 15 bits for the colors, you have the last bit is free, and you can use it for different things. Now it depends if it's uncoded or coded. And depending on the mode, no, it's the vertical table, 0 to 15, the 15th bit can be used. If you have a 6-bit, 8-bit, then some values, these are the colors. See, 5 bits, 32-bit color palette. It's really using the 5 bits. And the next bits, here it is, are used for various stuff. And I don't remember what these values are. It's so complicated. You can have possible VH bit. That's vertical horizontal, okay? It's the 2 interpolator. 2, 1. So in some video modes you can have one average for the horizontal or the vertical or whatever. There are some flags that swap the horizontal and the vertical. And then somehow, and let's finish this, because I can make, I'm just showing you. I'm taking longer with that, doesn't matter. I just want to make a point. Somehow, it's either the Y position or maybe the value on the palette. Somehow that affects, depending if you have this flag or not, instead of affecting the VH, it might be passing the VH, and then it's read from the VH to affect which one to select, if you want to use the extra color lookup table or use the fixed one, the default linear interpolated from 15-bit to 24-bit. That's just one thing of them, and I get why 4DO is not emulating this, because it's another detail, and maybe there is one or two games that use that, and the colors broke, and so Phoenix was trying to be more accurate. There is more than that. There is a vastness. You might see a lot of such schematics in various. In order to draw a single pixel in a 3D emulator, there are so many parts in the pipeline that it passes to decide how to paint the pixel or where to read from and where to blend it from, and if it's going to alter its global color lookup table or use the local or both or even interpolation. Now this and for example, as far as I know, the averaging this from 320 to 40 to a real 640 for 8, not the fake one from 4D, which is only for the cell polygons. This averaging, not only I cannot see it in practice, I cannot see an example on the real 3D. As far as I know, emulators don't emulate this. The 4DO emulator, I was looking at the 3DO weights from the game Kitty back in the time, and those bits, these VH bits, they were ignored. They might have been used to change the color palette at some place, but they were never used. So this is never emulated, and I don't know a game for sure that uses it. So there's so much stuff. Anyway, I got it too long at this point, but it's an important part to see how things are affecting and how there are still a lot of mysteries. Now, in the original 3DO, in my example here with my own 3D, I could use set screen color and others too. It was so easy with a single screen, but when you have your custom VDL, there is way more to do. I need to see how to create my own. And for that, I think there are some examples from 3DO. And maybe they don't do it the way Doom does it. Maybe they do it in a cleaner way. I don't know. But I need to see it because you can do some cool stuff, and if you don't want to bother with the cool stuff, you can change the palette easily with the high level functional. But if you want to go deeper, it's the rabbit hole is very deep of this hardware. And I'm surprised because you thought it was a very basic hardware. You think of the Jaguar and the Saturn with their complexities. And you think the 3DO, it has a texture interpolator and that's it. And the default video mode. But there is way more that happen that affect the pixel rendering in the pipeline. And way more cool tricks you can do. But man, those dogs are hard to follow sometimes. And I need to research that more. Anyway, guys, that's it. That's the madness of these things. Look at this. Almost cartoon. It reminds me of a Nintendo DS dungeon crawler I was playing in a way. Anyway, bye.